Hi, welcome to Automation Academy YouTube channel. I am Nimal Rathnoira. In this video we are going to learn fundamentals of PLC programming. There are 5 PLC programming languages are used to program PLCs. Those are ladder diagram, function block diagram, instruction list, structured text, and sequential function chart. Ladder diagram, function block diagram and sequential function chart are graphical languages, and instruction list and structured text are text languages. Ladder diagram, LD, which is commonly referred to as ladder logic, is the most popular PLC language because it was designed to replace hardwired relay control systems. It is easy to read, comment and debug. Ladder diagram is read from left to right and top to bottom. All of the contacts on the left must be true in order to energize the output coils. If you have a basic understanding of digital logic and conditional statements, ladder logic is easy to pick up. Those who are familiar with electrical diagrams may easy to understand PLC ladder diagram. The second most popular PLC programming language is called function block diagram, FBD. In function block diagram, program blocks are connected together to create a program. An added benefit to using function block diagram is that you can consolidate many lines of code into a single block. Third languages is structured text ST. Structured text looks very similar to BASIC or C programming. It is best used for control systems that require mathematics or complex tasks. Trigonometry, calculus, and data analysis can be implemented far easier in this language than in ladder diagrams. Because ST is not a graphical language, it runs faster and requires less memory. If you come from a traditional programming background, you can become proficient in ST faster than ladder logic or the other graphical PLC programming languages because the commands have a similar structure. Next is instruction list, IL. This programming language consists of many lines of code, with a single instruction per line. Instruction list is very straightforward to read, because each line is executed sequentially. Once you learn the mnemonic codes, instruction list a great language to create compact and time-critical codes as required by your application. Lastly is sequential function chart, SFC. The concept of SFC is simple. An action box is active until the transition step below it activates. The transition step contains all of the conditions that must be met in order for the next box to activate. If you're working on a project that has repeatable steps that can be broken into smaller tasks, then SFC is the easiest of the languages to implement. The advantage of using the sequential function chart is that you can break large processes into major steps, write the action box in whatever language you like, and then run your code sequentially based on the current state of the system. Now we will learn how to program PLC using ladder diagrams. There are horizontal ladder electrical diagrams and vertical ladder electrical diagrams. But for the PLC ladder diagrams, only vertical ladder diagrams are used. However, in PLC ladder diagrams use slightly different symbols. For example, normally opened input in PLC ladder diagram uses 2 small parallel vertical lines, and for normally closed input 2 small parallel vertical lines with crossed line. For output, PLC ladder diagram uses a circle, or a closed bracket. We need to name the inputs and outputs. A one step of the ladder we called rung. Then we will see what are the rules for developing a ladder diagram. Inputs and outputs must be named, and this is not correct and can be corrected like this. Any rung must have an output, and this rung has only an input. Then it is wrong. Any rung must have one or more inputs, and therefore this is not correct. Inputs must be written before the output, and this is wrong. Outputs cannot be in series but can be in parallel. This rung can be corrected as shown. This is wrong, because there is an input after the output. This is wrong, because there are same outputs in different places in the ladder diagram. This is also wrong, and can be corrected as shown. Different PLC manufacturers use different numbering systems for input and output addressing. ABB used numbering system with I0, I1, I2, and so on for input addressing, and for output addressing Q0, Q1, Q2, and so on. Allen Bradley used numbering system I0.0/1, I0.0/2 and so on for input addressing, and for output addressing, O0.0/1, O0.0/2, and so on. Omron used 0.00, 0.01, 0.02, and so on for input addressing, and 100.00, 100.01, 100.02, and so on for output addressing. Mitsubishi used X0, X1, X2, X3 and so on for input addressing, and Y0, Y1, Y2, Y3 and so on for output addressing. Siemens used I0.0, I0.1, I0.2, and so on for input addressing, and Q0.0, Q0.1, Q0.2, and so on for output addressing. However, for more detailed description of input and output addressing, we have to refer manufacturers' programming manuals. In the left side, you can see an electrical schematic diagram, and, in the right side, you can see the equivalent PLC ladder diagram, written for a Mitsubishi PLC. Now we will see the operation of this electrical circuit. If S1 is not pressed, K1 contactor is not energized and, through normally closed contact of K1, H2 green lamp is on. When you pressed S1, K1 contactor get energized, and normally closed contact of K1, open and H2 green lamp goes off. And H1, red lamp will on, because normally opened contact of K1 get closed. Then we will see how to develop a PLC ladder diagram for this simple circuit. For this we are going to use Mitsubishi GXWorks 2 PLC software. Open GXWorks 2 software. Then Project, New, we will get New Project dialog box. Then select the PLC series, and the type of the PLC. I will select FX CPU, and FX3U. Select project type as simple project and language as ladder. Then click on OK. Then click on the symbol of normally open contact. Type X1 on the dialog box, and click OK. Then click on the symbol of output. Type M1 on the dialog box, and click OK. Then first rung is completed. Then click on the symbol of normally open contact. Type M1 on the dialog box, and click OK. Then click on the symbol of output. Type Y1 on the dialog box, and click OK. Second rung is completed. Then click on the symbol of normally closed contact. Type M1 in the dialog box, and click OK. Then click on the symbol of output. Type Y2 in the dialog box, and click OK. Third rung is completed. Double-click on Global Device Comment, enter S1 for X001, red lamp for Y1 and green lamp for Y2. Go to ladder diagram. You can see the comments you have added. Go to Compile in the menu bar, and click on Build. Now ladder diagram is ready to write to PLC, or simulate. Go to Debug in the menu bar, and click on Start-Stop Simulation. After completing the 100%, close the Write to PLC dialog box. Now, we can see Y2 output or green lamp is on, through the normally closed contact of M1. Go to Debug in the menu bar, and click on Modify Value. Type X1 in the device box. Click on button. Now M1 get energized. Y2, green lamp will off, and Y1, red lamp will on. Click on Off button. Y2, green lamp will on, and Y1, red lamp will off. Thanks for watching. Please add your comments, subscribe if you like.